AP Calculus students. Welcome to section 5.5a. This is differentiation with bases other than E, meaning 2, 6, 5, 3, right? And again, it's mostly examples, which is kind of nice instead of lots of notes because you know so much already, how to differentiate, how to integrate. You're just now learning how to do, in this case, differentiation with different functions. And so I just put, all you really need to know is that the derivative of a to the x, where the base is a, is equal to the natural log of the base times itself, a to the x plus c. Of course, you may have a substitution when you integrate, you may have a chain rule when you do differentiation, right? So this is really the only formula you need here. And so here are our 4 examples. So again, we are just differentiating on 5.5a with bases other than E. All right, here we go. Number 42. They give you the function, just check and make sure I am recording. In fact, I am. Okay. So they give you the function 3 to the 2x and they ask for the derivative. So to talk your way through it, the derivative of a base of 3 to anything is the natural log of the base times itself times the derivative of the inside function. There, and normally, they would write the answer. They kind of tend to put the constant out front, followed by the natural log if it's a constant, followed by the base. I also want you to know that it could be written as, and it is in the book, though it kind of bothers me because they wrote this as 3 to the 2x. Notice they could have written that as 9 to the x, right? Whenever bases are, when you have one exponent raised to another, you multiply. So without the parentheses and with the parentheses, this is the same. 3 to the 2x is the same as 9 to the x. But they wrote it like they did. But in the end, their final answer, they wrote as 2 times the natural log of 3 times 9 to the x. Okay. No big deal. Just want you to know that in cases where it's a multiple choice question and you didn't see an answer that looked like this, you would understand that this is an equivalent answer. Number 46, product rule. They gave you x times 6 to the negative 2x. So we're going to talk our way through the product rule. Okay, so I'm going to take the derivative of x and keep my 6 to the negative 2x. Plus, I'm going to keep my x and take the derivative of 6 to the negative 2x. That would be the natural log of the base times itself times the derivative of the inside function. Now, what they tend to do is notice that because when you take the derivative, you are keeping a to the x, that it is a greatest common factor in both terms here. So they tend to pull this out, in case you're setting it equal to 0 and solving. That would leave a 1 here. Plus, that would leave a negative 2x, natural log of 6. Again, any order that you write this in here is fine. They just tend to put the natural log of 6 last, so it doesn't look like the x is with the 6, and so they tend to put a natural log last. Okay, let's see. Number 50 is also the product rule. They're asking you to take the derivative, but it has trig in it, a little bit more going on. They do use a symbol alpha, which is fine for most people. For me, my alpha looks a lot like a 2. So if it's okay with you, you're welcome to keep your alphas. I call them fishies. They look like, look, it looks like a fishy, right? But mine tend to look like 2s. So I am going to make mine x's. Okay, I'm going to talk my way through this, right? Product rule here. I'm going to take the derivative of 5 to negative x over 2. So that would be the natural log of the base times itself times the derivative of the inside function. And I'm going to keep my sign to x, right? I took the derivative of the first term and kept the second, plus I'll keep the first term and multiply by the derivative of the second term. Cosine, the derivative of sine of anything is cosine of anything times the derivative of the inside function, which is a 2. Now, I would have thought that because there's a 5 to the negative x over 2 in both of these terms, they would factor it out as always. And they didn't, which is weird. So let's just clean it up a little and then we'll be done with it. Let's see. Let's make our first term. Let's bring the negative 1/2 out front. Got this in front of the natural log of 5 times 5 to the negative x over 2. And we'll put the trig functions last. That's a heck of a first term. Plus, let's bring this 2 out front. Again, this is not 2 times 5. That's a 2 to the first power and a 5 with a different exponent. That's just a constant of 2 times a base of 5 to the negative x over 2 times cosine of 2x. And this will be our final answer here. Again, I would have factored 5 to the negative x over 2 out like they did here, like we usually do. They did not. There's no better way, one or the other. Now, number 119 isn't calc. It's actually like pre-calc, but just a little practice with simplifying expressions with natural logs and bases and things. Just wanted to give you a little practice on that. There's a couple ways to go. We could write this in logarithmic form. We could say, I'm trying to solve this expression. I'm trying to simplify this. I'm going to call it x. Okay. And I'm trying to solve for x. So let's take a look. X equals 9 to the 1 over the natural log of 3. All right, let's see what we can do with this, kind of play around with it a little bit. I think I'd like to bring this exponent out front and multiply it, but I'd have to take the natural log of both sides. So I'm going to do that. Let me give myself a little bit of room here. I think that might help. I'm going to take the natural log of both sides because I can. That allows me to bring 1 over the natural log of 3 out front and multiply it. I'm better at using it that way as a multiplication instead of as an exponent. That would be the natural log of x on the left. And this would be 1 over the natural log of 3 times the natural log of 9. Right? Or I'm just going to do a little erasing here. That would be, I could have simply wrote it as the natural log of 9 over the natural log of 3, right? Well, I don't see any math I can do here. It would be nice if I had a natural log of 3 or a natural log of 9 that canceled out. Let's try this. The natural log of x equals, let's write our 9 as the natural is 3 squared. Okay. Still feel like I can't cancel though, you know. But I can use the power rule here to bring the 2 out. I'm going to erase here. Give us some room. The natural log of x equals 2 times, and when I bring that 2 out front, then the natural log of 3 would cancel out from the numerator and denominator. Now to solve for x, I'm just going to write it in exponential form. This says when the base is e and the exponent is 2, that x is the answer. And my final answer, believe it or not, 9 to the 1 over the natural log of 3 is equal to e squared. I just thought it was interesting, and it's kind of good to play with this a little bit in different ways so that you get more familiar with it when you see it along with differentiation and integration. Have a good day.